Hey guys, how's it going? We are in Algebra 1, Lesson 32 today. We're talking about prime numbers as well as word problems, solving word problems, okay? So let's get started. First of all, let's talk about prime and composite numbers. Right here I have 6 and some factors of 6. I can make up 6 with the factors 3 and 2. 2 times 3 equals 6. Also, 1 times 6 equals 6. So I have more than one pairs of factors that multiply together equals 6. What about 35? Well, 1 times 35 equals 35, but so does 5 times 7. So once again, I have more than one pair of factors that comprise that number. Because I have more than just one in the number itself that can be factors for this number, I call this a composite number. So mathematicians have decided that numbers that have more than one pair of factors that comprise that number are composite numbers. But here I have 11. 11 I can only make with the factors 1 and 11. 1 times 11 is 11. 2 times nothing, no other whole number can get to 11. Not 3, nothing. So these are its only pairs of factors, 1 and itself. Same thing for 3. 3 equals 1 times 3, nothing more. That's a whole number. When multiplied together, it will give you 3. So, because it only has that one set of factors, it is a prime number. I can find the factors of numbers in lots of different ways, but sometimes when we're reducing and things like that, we might want to break a number down into just its factors that are prime. So just the prime numbers that compose a number. For example, let's look at the number 12 for a minute. I could write 12 as many different pairs of factors. 1 times 6, 2 times 6, 3 times 4. Those are the pairs of factors that go with 12. But there's also the prime factors that go with 12. Its prime factors are 2 times 2, times 3. 2 times 2 is 4, 4 times 3 is 12. So those are the prime factors of 12, just the prime numbers that added up together equal 12. So how do I find those prime factors? Well, it's very easy. We call it division by primes. There's a couple of ways that you can do this. I'm only going to show you one, because I think that this is the best method, personally, I think this is the best method to keep you from getting lost, to keep you from missing numbers or anything like that. I think this is the most organized method, so this is the only one that I am going to show you right now. If you've learned another method, you may use it as long as you get the answers right, okay? So here I have 80. I'm going to put what looks like an upside down division house because I'm going to go down as I divide. I'm going to start with the smallest known prime factor, which is 2. Always start with the smallest so you keep yourself organized. Now I divide. 80 divided by 2 is what? 40. Is 40 a prime or composite number? It's composite, so I need to keep dividing. I can still divide by 2, knowing that 40 is an even number. 40 divided by 2 is 20. Okay, is 20 composite? Yes, it is, so I'm going to keep dividing. Again by 2, because 20 can be divided by 2, so 20 divided by 2 is 10. Is 10 composite? Yes, it is, so I keep dividing. I can still divide by 2. 10 divided by 2 is what? 5. Is 5 composite? No, it's prime, so I'm done. I can't divide anymore. So these are the prime factors of 80. 2, 2, 2, 2, 5. 4 2's and a 5 make up the prime factors of 80. Okay, let's try 147. We'll draw our upside down division house. Can 2 go into 147? No, it can't. How about 3? Well, based on our division rules, yes, it can, because 1 plus 4 is 5, 5 plus 7 is 12, 12 is divisible by 3. So that's our next smallest prime number. So I divide 147 by 3, and that gives me 49. Is 49 prime or composite? Composite, so I keep dividing. Can 49 be divided by 3? No, because 4 plus 9 is 13. How about 5? No, what's our next prime number? 7. Can 49 be divided by 7? Yes, it can. 49 divided by 7 is 7. You should know that right off the top of your head. So, is 7 prime or composite? Prime. That means I'm done. So the way that I would want you to write this would be 147 equals 3 times 7 times 7. If you wanted to write 147 equals 3 times 7 squared, that's fine. Just make sure that you don't miss any numbers. All right, that's how you divide by primes. Let's move on now to statements about unequal quantities. So these are word problems that you need to solve with when you make an equation that's written out as words, you turn that into an algebraic equation, but the quantities are not necessarily equal. Okay, let me show you what I mean. For example, 32.3 at the bottom of page 129, it says, twice a number is 42 less than negative 102. Find the number. Okay, let's start with the first bit of information. Twice a number is 42 less than. So twice a number is, we already automatically know twice a number, that's 2n, and is an equal sign. Now I have 42 less than negative 102. Okay, when you see that less than symbol, if you see less than or greater than, cover that part up with your finger and write whatever comes after the than. So after the than is negative 102. Now pick up your finger. If it says less than, you need a minus sign. If it says greater than, you need a plus sign. So since it says less than, we need a minus. And then 42, because it's 42 less than negative 102. Okay? So now I can solve. I can solve by first simplifying on this side. Negative 102 minus 142, that's the same as adding a negative. So I have 2n equals negative 144. Divide both sides by 2, and n equals negative 72. Okay, to check this, all I need to do now is put the negative 72 in place of n. Two times negative 72 is 144. Negative 102 minus 42 is negative 144. My problem checks. Negative 72 is my answer. Okay? Let's try another one. Let's erase all up here. Okay. We have lots of space. 5 times a number is 72 greater than the opposite of the number. Find the number. All right, let's start with 5 times a number. So we have 5 times a number is 5n. Then it says is. Now I have 72 greater than. 72 greater than. So I'm going to cover that up with my finger, and I'm going to write whatever comes after it. I have the opposite of the number. Well, the opposite is always represented by negative and then the number, or the variable. Lift up your finger, 72 greater than. Well, if I have greater than, I add. So it would be negative n plus 72. All right, now I need to simplify. I'm going to add n to both sides. Gives me 6n equals 72. Divide both sides by 6. N equals what? 12. Very good. For time's sake, I'm not going to check this with you, but in your problems, you would need to check this. If by putting 12 in place of n here, 12 in place of n here, so you'd have 5 times 12 equals negative 12 plus 72. Okay, let's go on to the next one. If the sum of twice a number and negative 14 is multiplied by 2, the result is 12 greater than the opposite of the number. Find the number. Okay, let's start with the very beginning. We have the sum of twice a number and negative 14. Let's start with that. So twice a number added to a negative 14. Then it says if that sum is multiplied by 2, so all of this multiplied by 2. The result is, so that's our equal sign right there, 12 greater than, oh, cover up the 12 greater than, okay, what comes after it? The opposite of the number. Well, that would be negative n. Okay, lift our finger up, 12 greater than, is that plus 12 or minus 12? Plus 12, good. Okay, now I can simplify and solve. 2 times 2n is 4n, plus 2 times negative 14 is a negative 28, equals negative n plus 12. Okay, I'm going to add n to both sides so that I can move n over. And I get 5n plus negative 28 equals 12. Since I have a negative, that means I need to add a positive to get rid of it. And that leaves me with 5n equals 40. Divide both sides by 5. N equals 8. And then you plug 8 back up here in my original equation, up here, not here, not here, up here in the original equation. Plug 8 back in there, and we'll see what you get. If you get a matching answer, then you did it correctly. Okay, one more. 5 times a number is 21 less than the opposite of the number. What is the number? Okay, I'm gonna move a little quickly because our time on the video is running out. I try to get these to be 15 minutes or less so that I don't have to break it into parts. Okay, so 5 times a number is, well, we can stop right there. 5n equals 21 less than, okay? Cover that up, right, and then write down what comes after it. Twice the opposite of the number. Well, that's 2 times a negative n, or we said we could write negative 2n. All right, it's 21 less than that, so is that minus 21 or plus 21? Minus 21, very good. Okay, I'm going to add 2n to both sides, so I get rid of that having two variables, and I get 7n equals negative 21. Divide both sides by 7, and n equals a negative 3. Plug negative 3 back up here in the original equation in place of n, and you get your answer. Okay, pause now to do your practice. Okay, better be pausing these. Letter A, you should have written it out as 8n equals negative n plus 36, and it would have gotten you n equals 4. Letter B, you should have written it out as 2 parentheses n plus 6, close parentheses, equals n plus 10. And gotten as your answer n equals negative 2. Then letter C is 2 times 2 times 2 times 2. So you have 4 2's times 5 times 5. So if you said 2 to the 4th power times 5 squared, that's fine. Letter D, 2 times 2 times 3 times 3 times 3. So you have 2 squared times 3 cubed. Okay, hope that you did well. Let me know if you have any questions. I will see you in the next lesson. Love you guys very much. Bye.